This is one of the pieces of equipment that we kept from the old facility. It used to reside outside and we brought it in indoors. And basically it's a fluid transfer unit. You're just moving liquid around. It's got a heat exchanger involved and there's a compressor outside of the door there. And the compressor's outside because it's noisy. So we keep it outside. But a lot of the training we do in this lab, and you see behind you on the computer screen, that is the control or the DCS for this unit. But oftentimes this unit is run manually, just with hand switches and pumps. But we also use this lab. It's probably used more often, not running. And I'll give you an example of that. Pemex, if y'all are familiar with Pemex, used to be Shell. As operators, not only your backgrounds, but operators have to requalify either every year or every 3 years, depending on their area and whether they're PSM or not. Pemex had 500 employees that they wanted to requalify, and they did that here this year. So they brought them off site over 13 Tuesdays and spent some time in a couple of our other labs, and then they would come in here and do their lock, pack, and try training. We've got an MCC bank here. It's not hooked up to anything. It's just to simulate. But part of their training is they brought a game box in and we kept it here for them. So they had their own lockout packs, their own car seals, all their same, everything they're familiar with. But they would do that training here. So that's something else that we do. But this is a great lab for our process technicians. Again, I mentioned drawings. So as an operator, you're expected to draw the unit on paper and learn the unit. But we have them started here because it's color coded and it's not insulated. So it's real easy to follow. Now there are some quirky things in here. I've tried to line this thing up a couple of times and had to go around a few times. It's not as easy as it might look, but it is easy to draw compared to, like I said, when you're covered in insulation and things are 5 miles long. So those are some of the things that we teach in this particular lab. These are our Emerson performance learning platforms. So basically these are almost kind of a smaller version of what you just saw over there, but a newer version. And all of our technology here, most of our DCS or all of our software is Delta V. Where I came from OxyChem, and most of those plants were acquired, so we have 5 different systems. But as we get, as companies grow, a lot of them are moving to Delta V, so industry said Delta V is what we recommend. Now I know there are some lots of other software that may be just as good, but that's why we chose Delta V. So these are built on Delta V, and I'm going to show you this one because the screen's on. But basically, we've just got 2 tanks and fluid transfer. We're pumping fluid back and forth. And on the instrumentation level, there's lots of extra Cadillac instrumentation on here that's overkill for this type of system, but it's there just to teach the technology to the instrument students. So they can really delve into how does this instrument operate? What challenges might you have with that? How do you calibrate it? The operator level, the operation side, is kind of at the 30,000 feet. They're going to run this equipment. And an example we would have is we put students in here. We have one person at the screen, that's your board operator, and then we have 1 or 2 people at the skid. And again, a lot of our students don't have any experience, so their first thing is to go through a checklist. And for example, the first thing is a 5 valve 101, which is one of these gray mushroom valves. And then we would have them stroke the valve and verify the percentage. Well, how do you know visually what percentage is it at, right? So we can start real basic in here, but as we get a little bit more advanced, there's just a simple startup and shutdown program. And when they get it running, we have bugs built into the software. Something's not going to work. Okay, so for example, your 102 valve is not operating now. We need you to how do you fix that? Well, you're going to have your outside operator run the bypass, right? But that may be new to somebody, right? So some simple things. Other things we can do to them is somebody mentioned starting simple, right? They can't get the thing to run. Well, that's it. The emergency stop button is pushed, right? We get them with that about 1 time, then they learn. But it's again, it could always be something simple when you're trying to figure out why won't this thing run? Well, it could just be your power button. Okay. These things, they're about $150,000 a piece, and we bought extra and we rent these out. So for example, we've had one in Louisiana. Celanese just brought one back, and the cool thing is if you don't want to spend $150,000 on one, you can rent one from us. And so they were purchased with that in mind. And we have had them rented out several times. And they're all basically the same, except there are 3 types of meters. We have Vortex, Meg, and Coriolis meters up on the top. So the very top flow meter, this is where you'll see the difference. I don't know if you can see me here. Right here, the very top flow meter is where you would see the difference. And then you can see this one and that one are different. And then the Coriolis is over there by the door. There's Coriolis meter on the top. Outside of that, they're basically the same. And we have glycol and water that we're pumping around. And that's basically, we like glycol and water here. We use sewer grade glycol. That way if it does spill, we can wash it down the drain. And we don't want to drink it, but it's not going to hurt anybody, right? So again, safety is our number 1 concern here with our students as they're learning. Something here I mentioned in this unit, we start and stop it all the time, right? Well, they needed to know what the plant would look like if you ran it continuously, and we just don't do that. So we did an 8-hour run, and we ran it at what we felt was minimum, medium, and maximum, and we learned what our maximum was because we've never done that before. We also learned we had some other limitations when we're running at that speed. So good information for us, but that project is ongoing. It's sitting with them now where they're the I&E folks or whoever does AI, and you know, there's a low fidelity and a high fidelity model, if that means anything to y'all. I don't understand it real well, but I know that they're gonna have a computer running this thing at some point, so that's their goal. That's their goal. So in here, this is where the students would run just like a normal control room. Well, it is a real control room. The flooring is built, you know, there's wiring underneath just like you would have in a standard control room. Our credit students, they don't get in here until really their last year, right? So they spend some time in the unit tracing pipes and all that, but this is one of their capstone classes. On my side, the upskilling or incumbent working, you know, I'm working with newer operators that either have a P-Tech degree or some experience already, or engineers. They're going to run this thing. If they're here 3 days, we're probably going to run this thing. That's going to be part of it because they're at a higher level, right? So a lot of trainings we do, they do train in here. So here again, DCS, and then that's the plant there, and we'll step out there and I'll show you a little bit more about that. But the blinds right here, those come down because normally you don't know where your outside operator's at. So just because they're close to us, we don't want you to have, hey, you're in the wrong side of the plant. And again, the plant, there's not that much to it. Again, you know, it's not 5 miles long like, you know, a normal plant might be, but we don't want them to know where they're at, you know. So we will close the blinds on them, and they use radio, so we're teaching radio etiquette. You know, we're making sure they understand how to communicate when you don't know where somebody's at. We have an engineering station in the back that the students can't use. Then that's where the higher level, so there's some things in here they probably wouldn't be able to do, but like if we want to go in and throw a curveball at them, we could do that out of mind. But a lot of our troubleshooting here, honestly, and something else I'll tell you that is different for me, like right here, here's the 2 pumps. You know, the control room I worked, I could start and stop those from the DCS. These are set up manually by design because we want that communication. So they can only give a command that it should be on or it should be off. They cannot start and stop the pump from here. So again, that was put in there by design. Even though modern technology, you can have it all run from here, we don't do it that way specifically, so they have certain interaction as they're learning to operate the equipment.
So I'm going to be speaking a little bit later on motors, and we're going to dive into more of the maintenance side of it. But since we were here today, I figured we'd just bring our Sprinter van. We take this around to customers, and we'll do training in it. So we have it all powered up, so we can light up the soft starts and the drives, and we do training inside the van, and it's great for lunch and learns. We show the features and benefits of our products, but it's also a basic 101 on motors and stuff too, talking about the different seals that are in motors, the different ways the leads come out, and all that stuff. So just showing this today to say it's a great tool versus, you know, you just walk into a customer and you put a catalog down and it's all great and everything, but when you can actually show it, they can touch it, they feel it, and it's been a great tool down in the ship channel here, as you see, you know, young students coming out and working, or the older guys in the plants too. So it fits all those different scenarios, and it makes it fun for me too, because it says, hey, you want to see the demo van, you know, like the demo van. So, but it's a great tool, and I know years past we had a race car trailer full of stuff, and the guys would drive it around like me, would rip the side off of it going through a toll booth or something. So we decided we have 7 of these vans throughout the country, and so it's, like I said, a great sales tool. But you know, feel free to walk through and see what's going on in there. I've had 25 people standing at the back, and it's hard sometimes to do that, but again, it just gets the notoriety of your products and all that to the masses pretty easily. So
a little bit about me. I've been in the pump industry doing surge analysis for 37 years. Anyway, more than that. Anyway, what I've got is a water hammer lab that I actually designed but was built by the University of Texas for demonstrating hydraulic transient surge and whatnot. And I've got handouts if people want to see a picture of what that lab looks like, and a schematic diagram of it, and some other stuff if you want to write down notes and whatnot. But what this lab does is it has a centrifugal pump that all right, so water comes out of a bucket that's in the middle of the whole lab center. suction, it goes through a centrifugal pump, goes through a solenoid valve, through a sight tube, spins a little rotometer here. Pressure gauge goes back underneath inside, and there's 250-foot cable, or coil of pipe tubing. It comes back out through a downstream pressure gauge, and then that splits at this cross, and it has a surge accumulator tank, very small. It has a line to a pressure relief valve, and then it has a downstream solenoid valve that dumps back into the bucket. And when I run the model, I can demonstrate what happens when I close a downstream valve and the pressure goes up to, from atmospheric pressure up to about 70 psi. And then I can test to see what happens when I open up the pathway and activate the pressure relief valve right here. And it's set at opening at 30 psi, and it will basically cap the surge pressure, but it'll overshoot. It'll go up to maybe 35, 40 psi before it comes back down and dumps back into the bucket. And I can turn that off, isolate it, activate the surge accumulator tank, and we'll see a very slow, gradual rise in pressure. So I'll go ahead and start it, and this will make a bit of noise, so I'll have to talk over the top of the noise. All right, if you want to gather around and look at the pressure gauges, the discharge pressure coming from the pump through the sight tube, and it's sitting around 30 psi. And then the downstream is sitting at atmospheric pressure. And when I close the downstream valve, you'll see what happens, and watch this gauge, and the pressure will go up. And the upstream pressure goes to shutoff head at 34 psi. So try that again in case you missed it. Alright, so that's supposed to capture what pressure shot up to about 70. And the magnitude of the pressure rise here gets capped by the opening of the relief valve. The rate of pressure rise is still quite high, but it gets capped at the pressure spike on the high end. Alright, now what I'm going to do is turn that off, open up the surge accumulator tank, and this is the pressurizer there. There's a Schrader valve here to take a bicycle pump, put air in there. Alright, so how gradual now, we have a gradual rising pressure. It's a very slow, well-behaved rising pressure. Anyway, by comparison, we can see that if there's no surge control devices installed, the pressure spike goes up to 70 psi. With the relief valve, it may go up to 40 to 50 psi and then come back down and hover around 30. And with the surge accumulator tank, it goes up to 35 or so, and it's a gradual, gentler rise in pressure. So the other thing I'll do now is to test what happens when I close the upstream valve, and that will pull a vacuum in this piping, and we'll see a vapor cavity that is formed.